Our last conic section is the parabola, and it's very appropriately named because if you'll think about how a parabola is created, it's when that plane slices through that conic section at an angle parallel to the angle of the side of the cone, parallel parabola. Let's explore these a little bit on Desmos. Parabolas can open up, down, left, or right. So the standard form of one opening up or down is x squared equals 4 times p times y. Now you'll notice I've got a couple of things labeled on these. One of these is the focus. We're familiar with parabolas. We've seen these in other courses, particularly ones that open up or down. But we will look at ones that open right or left as well. So here would be the vertex. The vertex of this parabola is at 0, 0. The parabola doesn't have a center. It has a vertex. So everything that we would equate with center, we're going to equate with vertex in the parabola. Now, inside the parabola, we have a focus. We've seen this in other conic sections as well. Outside of the parabola, equidistant from the vertex, is a line called the directrix. And you'll see my little setup here in Desmos. If I slide P, notice what happens. The focus goes away, the directrix moves away. As I bring P closer to 0, the distance gets closer and closer. But you may notice that the distance between the focus and the vertex is the same as from the directrix to the vertex. In fact, that's the definition of a parabola. More generally, if you take any point along the parabola, any point, and you draw a line from this point to the focus and this point to the directrix, those two distances will be the same. So that's what we mean by a parabola, or what defines the points of a parabola. If P is negative, notice what happens. The parabola is now opening downward, but the relationship between the focus and the directrix stays the same. We will deactivate our up or down parabola and take a look a little bit here at the left and right parabola. Notice if a parabola is opening to the right, the focus is to the right. If it were opening to the left, the focus would be to the left, as we see here. So we still see this directrix, but this time it's vertical. What's a little bit harder to see, and I didn't point out in the parabola that opened up or down, is this line that goes through the vertex and the focus. You may remember from previous courses, that line is called the axis of symmetry. And no surprise, the parabola will be symmetric about that line. We'll also talk about a line segment called a latus rectum, or a focal chord. That segment will be a segment that passes through the focus with endpoints on the parabola. And that's how we'll identify some points on the parabola. Of course, there are infinitely many. So with the parabola, we talked about the definition of that. I've got a general one that I want us to use here to talk about some different things. So we have a vertex. In this case, this is at the origin. Inside the parabola, you will have a focus. In the opposite direction, you will have a line called the directrix. It's kind of a fun word to say, directrix, as you see here. You will have a line perpendicular to the directrix that passes through the vertex and the focus, called an axis of symmetry. And the last piece of information that we'll discuss is a segment that passes through the focus with endpoints on the parabola itself. That segment is called a latus rectum. In Latin, straight line. I know it kind of seems like a funny word. Also known as a focal chord. Different sources may refer to these interchangeably. Okay, so the points that will actually give us our parabola will be the endpoints of this latus rectum and the vertex. Everything else is just something kind of interesting. All right, so one thing I did not tell you that was very, very important information is this quantity P. P is going to be the distance from the vertex to the focus. It will also be the distance from the vertex to the directrix. The length of the latus rectum is 4P. So that's the length of the latus rectum. Well, where is all this P business coming from? I'm glad you asked. For horizontal parabolas, meaning ones that open left or right, the standard form of the equation is y squared equals 4px. So whatever the coefficient of x is, that's 4p. Notice in parabolas you only have one squared term, and that squared term is by itself and everything else is on the other side. For vertical parabolas, ones that open up or down, the x is the one that is squared, and it's going to be equal to 4py. Again, we see this 4p as the coefficient of the linear part of the equation. So if we want to sketch the graph of y squared equals 8x, kind of using our new techniques, we want to identify some things. We want to identify how it opens, its vertex, the location of the focus, the location of the directrix, the equation of the axis of symmetry, the length of the latus rectum, and then we will graph the endpoints of the latus rectum, which will allow us to graph our parabola. So, how does this open? Well, when y is the squared, this is a horizontal parabola, so it's going to either open left or right. I always kind of think of, okay, if y has squared, that means there's a potential that it could hit y twice. That helps me remember that. It doesn't mean it necessarily will, but it could. So this tells me left or right, and the way I decide is by the sign of the coefficient. If it is positive, then it goes to the right. If it had been negative, it goes to the left. So this opens to the right. In this initial example, these are centered at 0, 0, but I think you can tell because nothing's being added to the y or the x that would be the case. All right, so we're going to kind of plot as we go. My vertex is here at 0, 0. I'm keeping in mind that this parabola is opening to the right. Almost everything else, though not quite everything, has to do with what P is. Well, in this case, 4P is equal to 8, which means P is equal to 2. That means my focus will be 2 steps to the inside of the parabola. Since the parabola is opening to the right, my focus is to the right. That location is 2, 0. The directrix will be the opposite direction. So to the left, 2. The directrix does not intersect the parabola. So if you're wondering how to draw it, you don't want to draw it so it goes into the parabola. You want it to be behind it, so to speak. There's my directrix. that's an equation, or that's a line, so it has an equation of x equals -2. My axis of symmetry will be perpendicular to my directrix, passing through the vertex and the focus. That's a horizontal line, so it will have an equation y equals, and it goes through the y-axis at 0. The length of the lattice rectum, remember, is 4p. Well, p is 2, 4p is 8, so the length of it is 8. Now, the focus is right in the middle of the lattice rectum. Let me scroll back up for a minute. Notice your focus is in the middle, so they'll have the same distance on each side of the focus to get to the endpoints of the lattice rectum. So 8 divided by 2 is 4. So I will go 4 up from my focus, 1, 2, 3, 4. 4 down from my focus, 1, 2, 3, 4. And I can now draw in my parabola. It started off good and then it went awry. The endpoints of that lattice rectum are at 2, 4 and at 2, -4.